Hi everybody, welcome back. We're going to work with another exponent property. This one is power to a power. So a good way to look at it is when you have power to a power, you multiply, just like the distributive property. So if we kind of go backwards for a minute and think of 3 times x plus 5. When we saw parentheses, we distributed by multiplying. What is 3 times x? 3x. What is 3 times 5? 15. So we multiplied to simplify it. The same idea applies when we have a power to a power, except instead of multiplying the big bases, we're going to be multiplying the little numbers. So let's look at this little example box. If I have something like 5 to the 4th power and I'm squaring that, I am going to multiply the little exponents. So 2 times 4 is 8, so this is rewritten as 5 to the 8th power. Now, because 8's a rather large number, we're not going to go ahead and simplify it, but you could always rewrite that as 390,625. If you have a variable like m to the 3rd raised to the 5th power, again, power to a power, you multiply. So 5 times 3 is, great job, so it's 15, so m to the 15th power. So in case you didn't get it from all of that, when you see parentheses, what do you need to do? Multiply. Awesome. So let's compare. If we have something like yesterday's, x to the 3rd times x to the 5th, this is a multiplication symbol. And we said yesterday when you multiply, you're really adding your exponents. So that is x to the 8th. What that means is I have 3 x's and I have 5 more x's. So how many x's do I have altogether? I have 8 x's. Well, x to the 3rd is differently. It's x to the 3rd written 5 times. So x to the 3rd, x to the 3rd, x to the 3rd, and x to the 3rd. And we said x to the 3rd is the same as x times x times x. So each one of those is, oops, I'm running out of room here. Oh no. So if we look here, how many x's do I have written down now? I have 15. That's why we have to multiply it. So let's look at our first example. 2 to the 4th raised to the 7th power. Well, what is 7 times 4? Great, it's 28, so it's 2 to the 28th power. That will give us a rather large number, so we can just go ahead and leave it as 2 to the 28th power. Again, 5 to the 5th raised to the 2nd power. What's 5 times 2? It's 10, so it's 5 to the 10th power. Again, that's a rather large number, so we're going to leave it as it is. Sorry, you guys can go ahead and erase this number 2 that's written there. That was a little typo. So we have p to the 4th raised to the 5th. What's 4 times 5? You're getting this. It's 20. Ooh, number 4 is where it gets a little bit more complicated. Do you remember what we write in if we don't see an exponent on a base? Good. We're going to add a little 1 with that 7. By putting that 1 in there, it reminds us that we have to distribute that 4 to the 1 and the 9. So I would rewrite this expression as 7 to the 4th power and p to the, what's 4 times 9? 36th power. Now 7 to the 4th power is okay enough to go ahead and break it down. So that's 2,401 p to the 36th power. So the big key that you need to take away from this, if there's not an exponent listed, put a 1 so you don't make a mistake in your simplifying. So let's go ahead and look at number 5. Again, I've got number 5 written 2 times there. So I have 2f times g to the 4th raised to the 2nd. So the 2f is just going to stay where it's at, but I need to multiply 2 times 4. And what is that? Oh, 2 times 4 is 8. So it's 2fg to the 8th power. Good. Same idea with number 6. I have my 2x. He's not in the parentheses, so that -2 is not going to get distributed. But it is going to go in for the y to the 2nd. So that's y to the, what is 2 times -2? Great, -4. Oh no, the alarms are going off. You have a negative exponent. A negative on the bottom or top has to get moved. So it's all about the base. Let's look at the bases. Does the 2 have a negative exponent? No, so he stays. Does the x have a negative exponent? No, so he also stays. But that y to the negative 4, not allowed. He needs to get moved to the bottom as a positive. Great job. How is this feeling to you? Same idea here. If you have multiple numbers in there, we already saw this. We need to distribute. So let's look at number 6. Number 6, that 3 does not have an exponent. So what number do I write up top? You guessed it, a 1, and I distribute. What's 2 times 1? 2, so it's 3 squared. And then go to the G. What's 4 times 2? 8. Great. Can I simplify that further? Great job. Yes, you sure can. What is 3 squared? 9. Awesome. So it's 9g to the 8th. Let's try 2 more like these ones. Okay, so let's look at number 8. Again, what number are we going to put up top with the 4? A 1. And again, we're doing that because I don't want you to do 5 times 4. That's not right. You need to do 5 times the little exponents. So 4 to the, what is 1 times 5? Good, 5. And then x to the 3 times 5 is 15. Now don't forget to go back and simplify. If we have an exponent that's smaller than, I would say like 7 or 8, then you should definitely be going back and simplifying. 4 to the 5th power is equal to 1024, and you still have your x to the 15th power. Good job. Number 9, they're trying to trick you here, but I think you'll be okay. Again, neither of my bases have exponents, so what am I going to put with it? Good, imaginary ones. So I'm going to rewrite that as 3 to the, what's negative 2 times 1? Negative 2. Then I have h to the, what's negative 2 times 1? Negative 2. And it's all about the base, Let's look here. That 3 to the negative 2, does he stay or does he go? You're right. He gets moved to the bottom as a positive. H negative 2, does he stay or does he go? You got it. Moves to the bottom as a positive. Now, a couple things I need to add here. What number goes up top to hold its place? Good, a 1. So 1 over, and what is 3 squared? Great, a 9, and then I have h squared. So all of our rules are coming into play here. I'm going to skip number 10 for right now, and I'm going to go on to the little bit more complicated ones. So if we look at number 11, we have 2 different sets of parentheses. So again, I'm going to add in any missing exponents before I go any further. This 2 is getting distributed to the first set of parentheses. So I have 2. What's 1 times 2? 2. Good job. And then I have r. Again, what is 1 times 2? Good job. Now I'm going to go on to my second parenthesis. This 6 gets distributed to the 4. So I have an s. And what is 4 times 6? 24. Great. Now, if I look here, I've got nothing more to combine together, so I can just simplify. 2 squared is equal to 4, and I have my r squared and s to the 24th power. I have no negative exponents, so I am done. Now I'm going to go on to number 12. In my first parenthesis, I have x to the power to a power u, multiply. What's negative 2 times 2? Negative 4. Great job. Now I'm going to go on to my second parenthesis, adding in any missing exponents. So 2 times 1, so it becomes 3 to the, what's 2 times 1? Awesome, 2. Then I have x to the, what's 1 times 2? You're on fire. And finally, y to the, what is 4 times 2? 8. Good. So now I'm going to go to my rule of multiplying. When I multiply numbers with like bases, or exponents with like bases, I'm going to add the exponents. So these 2 that I circled, they're both a base of x. So I need to add those exponents. So I get x to the, what's negative 4 plus 2? Good, negative 2. I still have 3 squared, which is 9. And I still have y to the 8th. I'm almost done. Now I have a negative exponent. So my final step is I have to go base by base and rewrite. Does the x negative 2 stay or go? You guessed it. He goes to the bottom as a positive. And then 9, does he stay or does he go? You guessed it, he stays. And y to the 8th, does he stay or go? Again, he stays, so y to the 8th. So my final answer is 9y to the 8th over x squared. Aren't we having fun now? Let's look at these last couple ones. I'm thinking that number 14 is the most challenging, so let's do that one together as our final problem. So let me look at my first set of parentheses. I am missing exponents, so I'm going to put my ones in its place. And then I distribute. So m, what's 1 times negative 4? Good, negative 4. G, what's 1 times negative 4? Awesome, negative 4. Done with that parenthesis. Now I have no missing ones in my second one, so I'm just going to distribute my exponents. So I have m, what's 2 times 6? 12. Then I have my g. What is 4 times 6? 24. Awesome. So now if I look here, I have some like bases, and what do you do when you multiply like bases? You guessed it, you add. So I have m. What is negative 4 plus 12? Good. It is an 8. All right, now I look what's in that circle. I have like bases again. So G, what is negative 4 plus 24? Awesome, 20. Do I have any negative exponents? Nope. So I'm all done. And that concludes our lesson of a power to a power. So remember, when you have a power to a power, you multiply, multiply. If you have any questions at all, feel free to ask your teacher, or of course, you can always watch this video again. Thanks a lot. Have a great day. Bye.